So now we're going to take a look at some of these problems using the mole map. And again, do not feel obligated to use this map. Some of you will find great benefit in using this map and some of you will not need it at all. You will notice again that the mole is in the middle because the mole represents a unit that connects all quantities of matter. It's the link between mass and particles and volume. So you can probably imagine that eventually we're going to be able to go from mass to mole in the middle and get to particles, or start with particles, go to mole in the middle and get to mass. That's a couple days away. So today we're going to take a look at focusing on going from mole to mass. The first arrow that we're going to look at is the arrow that goes from the mole to the mass. And in the middle it says periodic table to remind you to use your periodic table. When we convert from mole to mass, we're going to want to use the conversion factor of molar mass in grams over 1 mole. If you remember when we looked at Avogadro's number, there was a specific number up here, the 6.02. Why don't we have a specific number up here for molar mass? Because it is different for every substance. The molar mass of water is different from the molar mass of silver, which is different from the molar mass of copper 2 oxide, and so on and so on. We will always need to calculate molar mass. Now, if I'm starting at mass and I want to go to mole, I'm going to follow the arrow that goes from mass to mole and has, again, periodic table in the middle. So I'm going to need my conversion factor of 1 mole over molar mass. So you can see the conversion factor there of 1 mole over molar mass. So let's take a look at a couple of these problems. The first problem we're going to look at is how many moles are in 95.87 grams of tungsten. So here we have our number with our unit, so that is our given or our known quantity. Moles does not have a number with it, so that automatically tells me that is our unknown. So we are looking at starting at mass and ending at moles. So our given quantity is mass and our unknown quantity is moles. So that means I'm going to follow the arrow that goes from mass to mole. Now we take a look at how to set up our problem. Again, going from mass to mole, we see that we have 1 conversion in the middle and 2 blanks to fill in. So we start with our 95.87 grams of tungsten. We multiply that by our conversion factor, which we see again is our 1 mole over the molar mass of tungsten. Since it is just elemental tungsten, we can use the molar mass from the periodic table, which is 183.84 grams. So we put 1 mole over 183.84 grams. Our math then becomes our 95.87, so 95.87 times our 1 mole, which again, anything times 1 is just itself, divided by 183.84. So we have divided by 183.84 equals. Then we have our final answer here, which is a lot of decimal places, so that's why it's good practice to work on rounding to the second decimal. If these would have been all zeros, we would have been wanted to do 2 non-zero numbers. So we have 0.52. That 1 is going to allow the 2 to stay 2. So our answer would be 0.52, and we look at what our final unit would be. We see that grams would cancel, and we're left with moles of tungsten. So our final answer is 0.52 moles of tungsten. The last problem that we're going to take a look at starting is going from 0.43 moles of titanium 4 sulfide to the mass of titanium 4 sulfide. So here we have our number with our unit, so that is our known or our given quantity. We have our unknown, which is mass, as there's no number with this. When we take a look at our map on the right, we see that our starting quantity is going to be mole. We're going to follow the arrow that goes towards mass, which means we're going to want to use the conversion factor of molar mass over 1 mole. Remember, we need to calculate molar mass. And in this case, we are working with an ionic compound that we will need to calculate the mass for. When we look at setting up our problem, we see that we are going from mole to mass. So that gives us 2 blanks to fill in with a conversion on one of those blanks. We start with our known quantity, which is 0.43 moles of titanium 4 sulfide. Let's backtrack a little bit and see how exactly we got TiS2, especially if it's supposed to be titanium 4 sulfide. I look here and see that titanium is Ti. The 4 goes with titanium, so it's 4 plus. Using my periodic table of ions, I find sulfide is from elemental sulfur because it ends with "ide." Sulfur is S2 minus. That brings us to our swap the numbers down, drop the sign, and again, 4 and 2 can simplify into 1 and 2, and remember we don't write ones. So our final formula becomes TiS2. Now that we know what our chemical formula is of TiS2, we can more successfully calculate the molar mass of TiS2. Again, note I'm only calculating the molar mass when mass is involved in my problem. There will be problems in which mass is not involved, and you will not need to calculate mass. We set up our conversion factor, and we see that we are multiplying by the molar mass of TiS2 over 1 mole of TiS2. So how do we calculate the molar mass of TiS2? We see that there is 1 titanium and 2 S's. The mass of titanium from the periodic table is 47.867. So we multiply that by 1 to get 47.867. The mass of sulfur from the periodic table is 32.06. We multiply 32.06 to end up with 64.12. We then add those two numbers together to obtain a final mass of 111.987 grams per mole. So that becomes our molar mass of TiS2. Our final step is to take our 0.43 and multiply it by our 111.987 divided by 1. Putting this number in on the calculator, we go 0.43 times 111.987 equals. Now again, we could divide by 1, but remember, anything divided by 1 is itself again. So our final answer here is 48.15441. Again, a lot of decimals, so good practice. Round to the second decimal place. If you want to write those decimals, go ahead. But if we round to the second decimal place, this 4 right here would allow the 5 to stay itself. Looking at our final units, we see that mole and mole cancels, so our final unit is gram. And again, we have the chemical formula here to help us get in good practice for next week when we need to keep the chemical formula going from one substance to another. Bringing us to our final answer of 48.15 grams of TiS2. So go ahead and try some of the practice problems before you go ahead and check your learning for today. Please give some time to the practice. It is critical for understanding this information. During distance learning, it's very hard for us to understand or see what is truly known and where we need to help you with. Please reach out. Please ask for help. We're here for you. Take care. Stay healthy. Warm weather is on the horizon. Have a great day.